So welcome viewers. So in this lecture 3 we will find out the coordinate of center of curvature at a point on a given curve and the equation of circle of curvature, and after that we will formally define what is evolute of a given curve. So for that purpose consider this diagram where at the point P the radius of curvature is rho, and accordingly C, which is rho distance apart at the normal line in the direction of bending, is our center of curvature, and we have assumed that its coordinate to be x bar comma y bar. So now we will find out the values for x bar and y bar. For that purpose we have assumed that the tangential angle at P is psi, and we have drawn perpendicular CS and PQ over x-axis, and for that reason the angle SCP will be also psi, because the angle between PT and x-axis is psi. So CP is perpendicular to PT and CS is perpendicular to x-axis. So angle between them will be also preserved, which is same as psi. So now to find out the coordinate of x bar comma y bar, what we will observe that here this RP is nothing but x minus x bar, because OQ is x and OS is x bar. So SQ, which is same as RP, will be x minus x bar. Similarly, this CR will be nothing but y bar minus y, because CR is nothing but CS minus RS, and CS we have assumed to be y bar, and RS is same as PQ and it is 1. So from this figure now we are ready to find out the value of x bar and y bar. From the triangle CRP, what we can observe that x minus x bar, it is nothing but rho sine psi. Now we know that tan psi is nothing but dy dx, which we denote by y on shape. So from here what will be the value of sine psi? From here the value of sine psi, so we can consider this like, because value of y on is tan psi, so we can consider this like perpendicular by base, perpendicular by base. So from that value of sine psi will be perpendicular, which is y on, divided by hypotenuse, which is divided by 1, we can consider like this. So 1 plus y on square, which is the hypotenuse by Pythagoras formula. So if we substitute it here, so what we observe that x bar is nothing but x minus rho y on divided by root over 1 plus y on square. But we know that in Cartesian coordinate, rho, radius of curvature, was nothing but 1 plus y on square whole to the power 3 by 2 divided by y2. So if we plug this value here, so it will turn out to be x minus y on into 1 plus y on square divided by y2. So this is our x bar. And similarly from the triangle CRP, y bar minus y is rho cos psi, and by similar concept cos psi is 1 by root over 1 plus y on square. So this will finally turn out to be 1 plus y on square divided by y2. So that means from here y bar is nothing but y plus 1 plus y on square divided by y2. So what is the coordinate of center of curvature? It is x bar comma y bar, and it is given by x minus y1 into 1 plus y1 square divided by y2 and y plus 1 plus y1 square divided by y2. So what will be the equation of circle of curvature? So the equation of circle of curvature is nothing but the equation of the circle centered at C with radius rho. That means x minus x bar whole square plus y minus y bar whole square is equal to rho square. Where x bar, y bar and rho is nothing but radius of curvature, are given by these three formulas. X bar is this, y bar is this, and radius of curvature rho is given by this formula. So now we are at a point to formally define what is evolute of a given curve. See, as the fixed point P changes over the curve, the center of curvature, which was previously C, it will also change. It will also change like this here. As the point on the curve changes, the center of curvature will also change. So locus of the center of curvature will be called evolute of the given curve. So now we will formally define what is evolute. So what is evolute? So evolute of a given curve, it is the locus, of center of curvature. We will solve few problems and see how to find out the evolute of a curve. So how to find out the evolute of a curve? What will be the working formula? So find center of curvature C at a arbitrary point xy on the given curve. So once we have found out the center of curvature at an arbitrary point, then what we have to do? Then eliminate x and y by the help of equation of the original curve, to obtain a relation in between x bar and y bar, and it will denote the equation of the development. Involute. So if y is equal to g of x is evolute of the curve y is equal to f of x, then y is equal to f of x, this curve the original graph of which evolute we have found out as y is equal to g of x, then y is equal to f of x will be called involute of the curve y is equal to gx, which was actually evolute of fx. So now we'll discuss few problems where we'll learn how to find out the equation of evolute. So let us consider the examples one by one. Center of curvature and equation of circle of curvature at the point 3, 1 of the curve y is equal to x square minus 6x plus 10. So what will be the solution? So we just need these three expressions. So by this formula we can find out the coordinate of center of curvature, and by using the second formula we can find out the circle of curvature. So for that we'll find out y1, which is dy dx as 2x minus 6, and y2, which is d2y dx square, which is 2. So y1 at the point 3, 1 is 2 times 3 minus 6, that is 0, and y2 being a constant evaluated at 3.1 is also 2. And in this case the point xy is nothing but 3, 1. So what will be the center of curvature? The center of curvature is x bar and y bar. Then we know that x bar was nothing but x minus y1 into 1 plus y1 square divided by y2, and y by y bar was y plus 1 plus y1 square divided by y2. Okay, so in this case 1 plus y1 square divided by y2 at the point 3, 1 is 1 plus y1 at the point 3, 1, which is 0. So 1 plus 0 is square divided by y2 is 2. So this is simply half. So the center of curvature is 3 minus y1 is 0. So this turns out to be 0. And is in this case 1 plus y1 square by y2, which is half. So this is simply 3 and 3 by 2. So this is the center of curvature. And what is the equation of radius of curvature? So for that purpose we will find out what is the equation of circle of curvature. So for that purpose we will find out the radius of curvature first. And for Cartesian equation we know that radius of curvature is 1 plus y1 square whole to the power 3 by 2 divided by y2, and in this case this turns out to be 1 plus 0 square whole to the power 3 by 2 divided by y2 is 2. So this is half. So circle of curvature is given by x minus x bar. X bar is in this case 3 whole square plus y minus y bar is 3 by 2 whole square is equal to rho square 1 by 2 whole square, that is equal to 1 by 4. consider this example 2. So find evolute of the parabola y square is equal to 4ax. So for that purpose, we will find out first the coordinate of center of curvature at an arbitrary point xy on the given curve. Let what is the solution? So let x bar y bar be the center of curvature at xy on the curve y square is equal to 4x, which is nothing but a parabola. So what is y1 in this case? So we have y square is equal to 4ax, so which gives 2y times y dash, which we denote by y1 as 4a. So from here we obtain y1 as twice a by y, but y is again, as y square is equal to 4x, so y is again 2a to the power half x to the power half. So this is turned out to be a to the power half divided by x to the power half, and y2 it is dy1 dx. So this is a to the power half into minus half x to the power minus 3 by 2. So this is minus a to the power half divided by twice x to the power 3 by 2. And so what is the value of the expression on plus y1 square divided by y2? This turns out to be on plus y1 square is a by x divided by minus, so minus we can plug it here, a to the power half and twice x to the power 3 by 2 here, equal to minus twice x to the power half we can take outside, and if you take x inside, this will be x plus a divided by a to the power half. So therefore x bar is equal to x minus y1 is a to the power half y1 into 1 plus y1 square divided by y2. So this is x minus y1 was a to the power half divided by x to the power half times minus twice x to the power half divided by a to the power half into x plus a. So which turns out to be x, this a to the power half gets cancelled out, this also gets cancelled out, so x plus twice a, so this is 3x plus 2a. Similarly y bar is nothing but y plus 1 plus y1 square divided by y2, so this is simply y minus twice x to the power half divided by a to the power half into x plus a. But from the equation of the curve, y is nothing but twice a to the power half x to the power half minus twice x to the power 3 by 2 divided by a to the power half minus twice a to the power half x to the power half. So this gets cancelled out. So y bar is finally minus twice x to the power 3 by 2 divided by a to the power half. From this 1 and 2, we will try to eliminate x and y to get a relation in between x bar and y bar. So how to do that? So we will simply plug the value of x from equation 1 in equation 2, and thus we obtain y bar is equal to minus twice divided by a to the power half, and from the first equation value of x is x bar minus twice a divided by 3. So this whole to the power 3 by 2. So if we square the both side, this turns out to be y bar square is equal to 4 by a into x bar minus twice a whole cube divided by 27, that is 27 a y bar square is equal to 4 x bar minus 2a whole cube. So this is the relation in between the coordinates of center of curvature. So therefore locus of x bar comma y bar is nothing but 27 a, let us denote by capital letters, a y square is equal to 4 x minus 2a whole cube. So this is our evolute. So this is our evolute of the given curve. Thus the problem is solved. Find evolute of the asteroid x to the power 2/3 plus y to the power 2/3 is equal to a to the power 2/3. So the asteroid looks like this, where this much distance is, so this point is a comma 0, this is 0 comma a, this is minus 0 comma minus a, and this point is minus a comma 0. Okay. So for this problem, instead of directly using the Cartesian formula, we will consider the parametric formula of the asteroid. So what is the parametric formula? It is given by x is equal to a cos cube theta and y is equal to a sin cube theta, and you can check that it will satisfy this equation. Okay, because cos square theta plus sin square theta which turns out to be 1. So from here, what is dx d theta? It is 3a cos square theta into minus sin theta, and similarly dy d theta is thrice a sin square theta cos theta. Therefore y1 dy, which is actually dy dx, and it can be written as dy d theta divided by dx d theta. So this will turns out to be, everything will cancel out, so there will be minus here, and sin theta by cos theta, so this is minus tan theta, and from here y2, which is d dx of y1, but we can write it as d d theta of y1 into d theta dx using the chain rule. So this turns out to be minus derivative of tan theta with respect to theta, that is sec square theta into d theta dx is minus 1 by thrice a cos square theta sin theta, and this turns out to be sec to the power 4 theta cosec theta divided by 3a. So now value of the expression 1 plus y1 square divided by y2, this is 1 plus tan square theta divided by y2 is sec to the power 4 theta cosec theta, and thrice a will go here. Now 1 plus tan square theta is sec square theta, so this will be further written to 3a sin theta cos square theta. Therefore x bar will be x minus y1 into the expression 1 plus y1 square divided by y2. So this is x minus y1 was minus tan theta, so this is plus sin theta by cos theta into thrice a sin theta cos square theta. So this is simply x was a cos cube theta plus cos theta will get cancelled out, so this is thrice a sin square theta cos theta. So call this equation 1. Now similarly, what will be y bar? Y bar is y plus 1 plus y1 square divided by y2, and y was nothing but a sin cube theta plus thrice a sin theta cos square theta. So call this equation 2. So from these two equations we have to eliminate theta. In this case we have to eliminate theta to get a relation in between x bar and y bar. So how we can do that? Let us try to find out what is this summation x bar plus y bar. This turns out to be, if you take a common, then this turns out to be cos cube theta plus thrice cos square theta sin theta plus thrice cos theta into sin square theta plus sin cube theta. So this is the formula for a plus b whole cube, that is cos theta plus sin theta whole cube. And similarly, if we find out the value of x bar minus y bar, then we will observe that this will be a times cos cube theta plus thrice sin square theta cos theta minus thrice sin theta cos square theta minus sin cube theta. So just think it of it here and this as here. So this is simply the formula for a minus b cos theta minus sin theta whole cube. We have to eliminate theta. So for that, from here what we can do, or if we consider x bar plus y bar whole to the power 2/3 plus x bar minus y bar whole to the power 2/3, then it will become a to the power 2/3 we can common, and it will be cos theta plus sin theta whole to the power 3 into 2/3, and similarly cos theta minus sin theta whole to the power 3 into 2/3. So this is a to the power 2/3. So this is simply square, this is also square. So cos square theta plus sin square theta, that will be 1, plus sin square theta plus cos square theta, that will be 1, and twice every term will get cancelled out. So this is simply twice a to the power 2/3. So this is the relation in between x bar and y bar, and hence we have evaluated the locus of x bar y bar. Therefore equation of evolute of the asteroid x to the power 2/3 plus y to the power 2/3 is equal to a to the power 2/3 is, we can write it by capital X plus capital Y whole to the power 2/3. It is in implicit form. capital X minus capital Y whole to the power 2 third is equal to twice A whole to the power 2 third. So it is in implicit form, not directly in Cartesian form.